Hello friends, welcome back to the bench. Today we have an ECM, and this ECM is here for a recapping. Now, why would you want to recap an ECM? Capacitors, pretty much everybody will tell you that capacitors is one thing that very often breaks because they age, and once they age they stop doing what they're supposed to be doing. And it's not usually, it's with the ceramic caps, they might just go short, so that's easy to find, the device will just stop working. However, especially the polymer capacitors or electrolytic capacitors, they don't go short. They either go open or slowly start losing capacitance. Usually the ESR goes up, and sometimes it goes all the way to negative when the cap is open. So it's, I would say it's a good thing to do once every, I would say maybe 5 years, especially on ECMs. On other devices it kind of depends, and the capacitors are rated for like 2, 4, 10,000 hours. It doesn't mean that the device can only work for 10,000 hours, but that's what they rate them for. So technically after that time the manufacturer will no longer guarantee that the capacitor will work as it did when it was new. How does it manifest on this board? So on this board we replaced, this is the board for Aaron from Ohio. We replaced, no, we didn't replace, we resoldered the IC608 responsible for fuel injectors. But I don't know if you guys remember, we measured this cap and pretty much all the caps showed abnormal capacitance. So I expected that those caps will need to be replaced. But what happened was kind of curious, because the car started and it was running fine until, running fine for, I don't know, minutes, pretty much minutes, I would say, if I remember correctly. And then it would start catching misfires, and then it would die and wouldn't start. So that's not usually what happens when you mess up soldering on the chip. And I know I didn't mess up soldering on the chip because, you know, at this point I've done enough of these that I can spot bad soldering when I do it, right? So I don't expect that this is soldering issue. So I figured let's replace the chip this time. So we're gonna take this chip off and replace it with the new one. And we're gonna do recapping. These are SMD caps. It's kind of tricky getting them off. So let's see how that is gonna go. Let's see. Alrighty. Now this is our ECM. This is Subaru Outback LLB 2008. This one, on the other hand, is also Subaru Outback, but this is H4 engine, this is H6 engine. And few similarities. Well, you can see they roughly are similar, but the fuel injectors are controlled by this chip on H4 and this chip on H6. But that's not really important. What you note immediately that we have 2 crystal oscillators on this board and only 1 on this board. We got 10 megahertz on H4, and this one is 10 and 6. So there's some separate circuitry over here that requires lower frequency. Now, what is curious about this is, take a look at it from this side maybe. And this board is powered with 12 to 16 volts. Power goes through here, basically, that big Zener diode, and we have the same one here. I don't know if it goes through here, but this diode is involved in the supply process. And we have two coils over here that produce 5 and 3.3 and two transistors, and the output capacitors, right? So when I connect 12 volts to these pins, I get 3.3 and 5 volts over here on the output. Simple enough. So of course these capacitors also need to be replaced because they're also showing abnormal ESR. However, on this one we see also two much bigger transistors, right, compared to these little ones. Two huge transistors and 4 capacitors and the same diode, and that's it. There's no coil, nothing. Some diodes in the back, because the diodes on this one, there's one over here and two over here on the back. Here we have no diodes. Here we have just two diodes here. So that is kind of, this is not what I expected, maybe let's put it this way. And there is a possibility that, or maybe there are two possibilities. Possibility number one, that this doesn't use inductive elements to drop down voltage. Maybe some linear drop downs, regulation, hard to say. The other possibility is that it is a buck converter without an inductive element. It's not very reliable. I know it's possible. I even built a circuit like that many years ago, and I was learning about converters, and yeah, it was kind of surprising to me that you can build the H bridge using a capacitor instead of a inductor. So maybe that's what's going on over here. Maybe I was thinking perhaps maybe one chip has like built-in coil. That's also technically possible if the coil is really small, but it has to deliver. The bottom line is that these chips need either 5 or 3 volts to be powered, and we supply 12 volts to the board. The car doesn't generate 3 volts or 5 volts. So this must be dropped somewhere here, and that voltage is used for supplying MCU and all these other things. So that being said, capacitors will have a lot to say whether how stable the voltage is, and sometimes even the level of the voltage, especially if the capacitors are being used here as a power element or instead of the inductor. Possible, very unlikely in my view, extremely unlikely. I would not expect that, but it's technically possible. All right, so first we're gonna replace the chip, then resolder a new one, and then we're gonna replace all these caps. So 220, that was no big deal. So what capacitors are we gonna use? We're gonna use the Kemet, whatever it's pronounced. And why these capacitors? These are very good for automotive applications because they come in variety of sizes and capacitance, and they have extremely low ESR. ESR on it is 22 to 27 milliohms. So on our meter we should read 0.003 at the maximum. These, well, let's test these. I already tested them, but let's test them again. So we have 220 and 47 microfarads. And that is from Mauser Electronics. They come like this. And these are the same size as these. These are a little smaller. But these boards are made in such a way that they can accept many sizes of these capacitors. So it's no big deal that the package is a little smaller. A little smaller. Obviously, you don't want to replace a huge cap like this with some tiny cap, even if they say that the capacitance is the same. And they're all 35 volts. Okay. That is what we shall do. Let's measure. Maybe first let's measure a new one, because I'm curious. Is it actually gonna have less than 30 milliohms? It should, right? That's right. Okay. Let's see if we can catch it. We're breaking it. It's not easy, but let's keep this maybe. 3940. It's a little higher than I expected. But in the range. They got 10% tolerance, but that's where it. No, 0.23. Yeah. So this is the ESR of these caps, and they will replace these. They're even a little bit taller than these. Now let's check the ESR of our existing caps. For a second, like this, and you want to see the carbide. Okay, and 130, 132. Right, that's the one that was showing abnormal. This is 0.6, 0.7. So huge ESR on this one, and that's 47 mics. So the low capacitance, the low capacitance. But it shouldn't be 0.7. This one is 220 and it's 230. And this one is 0.3. That's a little better, because this one is the same. This is the one that is 0.7, and 0.7 is way too high. So that's like almost 1 ohm of energy that we're losing on this one capacitor. Did I say 1 ohm of energy? Yeah, that doesn't make sense. Well, we lose energy on 1 ohm. The same here, 0.6, 0.7, and this is also 47 mic. So these all have really high ESRs. Now, is that a huge problem? It could be a huge problem. In this case, it could be a very big problem, since I don't see the coil. So why is the car dying? Maybe the caps are heating up slightly and lose that crucial tiny nanofarad of capacitance, and that causes the car to die. Could be. There's only one way to find out. Let's replace them, put it back in a car, and go from there. If it still doesn't work, then we'll see what we can do with that. Now let's see here. 608. There you go. Look, beautiful work. Job well done. Alrighty. So all the caps are replaced, except for this one that is bipolar. I don't have these, and I don't expect it to be the root cause of the rough running. However, these four are responsible for power supply. These three, I don't know what. I don't know what they're responsible for, but they must be here to do something. If they don't work, they're not going to be working. So this one or this repair should relieve the rough running. Aaron, thank you very much for your patience. The board is going to be on its way to you tomorrow morning. And the rest of you guys, thank you very much for watching, and I'll see you in the next one.